Hey guys, it's Mr. Peterson. I'm here. I'm going to work through these the two cheat sheets for today's lesson. So this first group of lessons is on volume and surface area. So this first box details all of the information you need to know about volume of 3D objects. So this first blank says the amount of blank a 3D object occupies, so takes up. Well, volume is the amount of space that a 3D object occupies. It's how many cubes it would take to fill it. So there's a formula for volume of a cylinder. It's V is equal to big B times the height. And of course, in this case, big B is the area of the base, which, since it's a circle, it would be pi r squared. So you would really do, on this, you would do pi r squared times height. For cones, also, you know what, before we go on any further here, we should probably label this that this is the base and this is the height. All right, with cones, it's the same idea. This is the base, and the distance from the apex of the cone down to the base, that is the height. So the formula for volume of a cone, it's the same one, but remember we can only do 1/3 as much. On a cone. So we do 1/3 times the area of the base times the height. And in this case, again, the base is a circle, so base would equal the area, or big B would equal the area of the base. So again, we could maybe simplify this or expand this out. This would be 1/3 times pi r squared times height. Spheres. The volume of a sphere formula. When we have a sphere, the thing we care about is the radius. So the radius is the distance from the center of the sphere to any endpoint. And that formula is special. That one is 4/3 pi r cubed. Don't forget that one is the cube. And all three of these are on your formula chart, so you shouldn't not know them or not have them with you on the test. All right, surface area. Well, remember, surface area is like the wrapping of the present, like the outside that it takes up. So for surface area, this would be the total to cover, or the total covering a 3D space. So with triangular prisms, the things that we got to keep in mind is that the triangles are the base. Just to review the idea of a prism has parallel and congruent bases. So even though this looks like it's laying on one of the rectangles, its bases are the triangles, and that's how we name it. This is a triangular prism because the triangles are parallel and congruent to each other. So this is a triangular prism. So this is the base, and so is this one back here. The height is the distance from the top of the prism to the bottom there of the triangle. That's the height of the prism. And then excuse me, that's the height of the base. We probably should be clear there, height of the base. And then if we tip this on the side, this would be the height of the prism. Well, when we did this in class, we've realized that there's two formulas for this, or they're on your star math chart. The lateral area formula, you can take the perimeter and multiply it by the height, the perimeter of the lateral base, or of the base, and multiply it by the height. And then for the total surface area, you can take the lateral, which is P times H, and add it to 2 times the area of the base. So again, in this scenario, P is the perimeter of the base. Height H is the height of the prism. B is the area of the base, big B. And then to find big B, in this case, we would have to use the area of a triangle formula, which is 1/2 times the base length of the triangle times the height of the triangle. Again, if this stuff confuses you, like if this doesn't work out for you, then please just draw a net and find the area that way. It definitely works that way. So this is just an alternate approach. If you're more comfortable drawing a net and going that way, then go that way. Rectangular prisms have a similar idea here. Again, this would be the base length, or this would be the base, and then this would be the height of the prism. The formula here again is the perimeter of the base times the height, and again the total area would be 2 times, excuse me, that's wrong, the perimeter times the height plus 2 times the area of the base. And again here, the P is the perimeter of the base, H is the height of the prism, B is the area of the base. And again, to find area of the base here, we would either do length times width or base times height. Either one, it's the same since it's going to be a rectangle. Again, if these formulas confuse you, just draw a net. Just draw a net, it's that simple. All right, cylinders. Well, in a cylinder, we would say that this is the base, and so is this up here. The base is a circle, so it's got a radius. And then this would be the height of the prism, or height of the cylinder, excuse me. So the lateral surface area, that would just be the rectangle here. Because remember, if we drew the net of this, I'll just sketch a net of this over here. We have something that looks like that. And so the lateral surface area is just this rectangular part. All right, lateral right there. And so the length of that rectangle is the circumference of the circle. So it's pi times diameter, or another way to think about that is 2 times pi times radius. And then you need to multiply that by this, which is the height of the prism, so times h. So it's really just length times width of that rectangle, but it's in reality it's the circumference, which is 2 pi r times the height. And then the total here, that would be the lateral, which is 2 pi r h, plus you've got 2 bases that you need to find the area of, so 2 pi r squareds. And again, h in this case is the height of the prism, and r is the radius of the base. Again, I would probably encourage you to draw a net of those. So I'm going to stop it here, and in a second here we can do the other one.